Well, I'm going to go ahead and start. Yeah, only 3 people here, but I say we get going at 12:40 and it's already 5 minutes past that. So we're going to talk next about one of the auxiliary organs of the digestive system, and that's the pancreas. Pancreas serves as both an endocrine gland and an exocrine gland. As an endocrine gland, it gives us certain hormones that help us regulate our blood sugar, as we have seen. As an exocrine gland, it secretes a digestive fluid called pancreatic juice. The pancreas gives rise to this particular juice with cells called pancreatic acinar cells. Pancreatic acinar cells. And these actually make up the bulk of the pancreas. They put tiny tubes that secrete the pancreatic juice. People can't be here on time, they have to just get caught up, sorry. The pancreatic juice mainly has amylase. We saw that in the saliva. It begins the breakdown of carbohydrates in the saliva, but the pancreatic juice has a higher concentration of it, and this is where the bulk of the breakdown of the carbohydrates takes place. It also has an enzyme called lipase, and you definitely need to get that. This is the main fat digesting enzyme. It breaks triglycerides down into fatty acids and monoglycerides.
Can you spell that, please?
Lipase, Lipase. You've also got 3 protein splitting enzymes. The first of these is trypsin, Trypsin. The second is chymotrypsin. And the third is carboxypeptidase. And basically, these break down any proteins or polypeptide chains. Due to the different types of peptide bonds, you can't have just a single acid or enzyme break down each one to amino acids. It takes the combined action of all 3. You've also got nucleases. Nucleases. The nucleases break down nucleic acids. Ribonuclease, which breaks down RNA, and deoxyribonuclease, which breaks down DNA.
You said those broke down what? I'm sorry.
Ribonuclease breaks down RNA.
And DNA?
Deoxyribonuclease. And finally, you have bicarbonate ions, HCO3-. This makes the pancreatic juice alkaline or basic. That in turn ensures that the excess acid from the stomach will be neutralized. Is everybody clear on that? And when we left off on Monday, I believe we had put the bolus into the stomach. Is that correct? So in the stomach itself, you have hydrochloric acid released, HCl. That HCl works to chemically break down the food, and it also activates an enzyme called pepsin, Pepsin. Pepsin also digests proteins. It essentially acts as a chopping mechanism. It chops big proteins into little chunks. Eventually, it reaches the end of the stomach. We talked about that secondary sphincter there, right? That opens up and releases the bolus of digested food into the first section of the small intestine. That is called the duodenum, And once the food is in the duodenum, the pancreatic juice gets added to it to complete digestion and to neutralize the stomach acid. It also shuts off the action of pepsin. And the reason for that, you don't want to digest your own duodenum. In the same location as the pancreatic duct, which puts the pancreatic juice in, you've also got the bile duct, And this is the source of two more accessory organs. The first is the liver. The liver is one of the most important organs in the body. It does not only do digestion. Is everybody clear on that? It also breaks down a lot of dangerous things. So there are 7 functions that go with the liver, and I want you to know all of these. They're not hard. The first one is detoxification. Removes toxins from the bloodstream. Best example or easiest example, depending on how you look at it, would probably be alcohol. So when you go to Scotland and you pull up to one of the distilleries, get yourself some scotch, You are essentially poisoning yourself. Yes,
So
sir.
if your liver is bad, what does that increase chances of happening? Like that wouldn't regularly. Like, would you be more prone to be getting sick or like getting
If your
specific
liver was
illnesses?
what?
Do what?
I'm not understanding your question. I didn't think.
So like if your liver was bad, because it filters all this stuff out and it does all these things.
Well,
what would...
you have to be a little more specific than your liver is bad.
So like say you have cirrhosis.
Okay, cirrhosis is scarring of the liver.
Mm-hmm.
Essentially, if you are a heavy drinker, your liver removes the toxin alcohol from your blood every day. You probably are going to drink more than your liver can break down. In other words, input never matches output. And make no mistake, ethanol is a toxin, pretty much any concentration. So as the liver is trying to filter that out, the ethanol is slowly poisoning it, so it dies. The liver has a limited regenerative capability, so it tries to rebuild itself and you get scar tissue. Over time, that scarring becomes worse and worse, and you eventually end up with liver failure. And when you have liver failure, pretty much your only options are a transplant or death. It's not necessarily as bad as it sounds, because if you have a close relative, they might be able to be a living donor. They could actually take part of their liver out and put it in you, and it will regenerate in you and in them.
Okay.
That help?
Mm-hmm.
It's a good question. If you get gutter crawling, commode hugging drunk one time, you're not going to go into liver failure. If you do that every night for a month, you're probably going to have some long-term adverse effects. That help? Okay. Second function is carbohydrate metabolism. Basically, this is the conversion of glycogen to glucose and back to glycogen. So you're alternating the storage form, which is glycogen. Everybody with me on that? When you need more carbohydrates in the blood, it will release the glycogen as glucose. When you have an excess of glucose circulating in the blood, the liver will synthesize glycogen from it and pull it out. Third function is lipid metabolism. Lipid metabolism. It oxidizes the fatty acids, so that breaks them down completely. If you have an excess of carbohydrates, more than you need to store in glycogen, it will convert them into lipid molecules to be stored as fat. Protein metabolism. It actually removes the amino group from the amino acids. This process is called deamination. Deamination. Basically, it forms it into urea, U-R-E-A. Urea is the main waste component of urine. That amino group is essentially an ammonia molecule, and your liver is what converts it to a less toxic form for your kidneys to filter and eliminate. Is everybody clear on that? It also stores energy. The glycogen, iron, blood, certain vitamins. It also acts as a blood filter. Damaged red blood cells, foreign substances in the blood. And then the final function is secretion of bile. Secretion of bile. And if you want to put all this together, it is summed up in table 17.7, page 218 electronic, 696 in the book. And just getting back to, you asked about damaged liver and how much you can actually regenerate the liver from as little as 25 to 30% of it.
And it can completely just...
Yep. Once it stops functioning completely, you're toast. So everybody okay with that? Am I going too fast? Okay, bile, B-I-L-E. This is a yellowish green liquid that contains bile salts, bile pigments, cholesterol, and electrolytes. The cholesterol is essentially a precursor to bile salts. The hepatic cells or liver cells use them to make the bile salts. The bile salts are the only ones that have a digestive function.
So when you have high cholesterol, does that affect your...
Depends on whether it's HDL cholesterol, high density lipoprotein, or LDL, low density lipoprotein. And the LDL is the bad cholesterol. It doesn't affect liver function. What it does is it helps plaques to form in your blood vessels, and those narrow the flow of blood. Pretty much the reason heart disease kills so many people, you notice it's not typically young people, is it? It's just an accumulation of things that build up over time. I can assure you, you all probably don't have anything to worry about unless you've got some kind of congenital condition. So eat all the eggs you want, Abby.
The protein.
So the bile pigments, there are two of these. The first is called bilirubin. Bilirubin. The other one is biliverdin. You ever heard of jaundice? Jaundice is when you get a yellowing of the skin and the eyes. It's basically due to a buildup of bilirubin.
What was the second one? Is bilirubin and
Biliverdin, V-E-R-D-I-N, B-I-L-I-V-E-R-D-I-N. These are breakdown products from red blood cells. And essentially they're added to the bile just as a way to dispose of them. And as gross as it sounds, these are one of the reasons waste is the brown color it is.
So when you have too much bilirubin, is it basically just breaking down too much red blood cells?
Yeah.
That's why
Well,
it's
there's
yellow?
a variety of things that can cause it.
Yeah.
You could have obstructive jaundice, which is where the bile duct gets blocked, typically by gallstones. You can have hepatocellular jaundice, which is going back to cirrhosis, damage to the liver, or hemolytic jaundice, and that's where you're breaking down too many red blood cells.
You think that would be the most common one? Do you think that's the most common one?
I'd say it's probably going to end up being hepatocellular because vast majority of the times there's an issue with the liver. It's going to probably be two, maybe three things. Number one is cirrhosis, and given the amount of drinking and heavy drinking and binge drinking that goes on, I'd say that's the number one cause. Number two is probably going to be hepatitis. Hepatitis technically just means an inflammation of the liver. We obviously commonly refer to viral diseases as hepatitis. The third, less so, but still possibility, would probably be liver cancer. Generally, if you have jaundice as a visible symptom, it's probably indicative of some kind of fairly extensive damage or malfunction. I don't want to seem like I'm soft pedaling this or just not going into detail, but there's so many different things that could cause it. The liver's a pretty amazing organ when you get down to it. I mean, look at all the functions we listed. Is everybody okay with that? And the gallbladder. The gallbladder is a small sac that's connected to the liver and to the hepatic duct. It basically stores bile until it's needed. So if you don't eat between, say, noon and 6 p.m., the bile that you're producing flows into the gallbladder for storage. If you end up reabsorbing too much water and electrolytes, the cholesterol will come out of solution and form crystals, and this ends up forming gallstones.
So what happens when you get your gallbladder removed? Like, what's the aftermath of that?
Well, they have a little balloon that is a drain that you have coming out of your gut that you have to keep drained for about 2 weeks. Got 2 scars here, 2 here, and 2 here.
Did you get your second out?
Mm-hmm. 2.5 years ago. And other than that, very little.
So like your body just kind of goes on.
More or less adjust to it, yeah. I have to be careful about eating too high fat a meal. I mean, you hear me joke about Baconators and Wendy's and things like that, but I am not going to order a Baconator from Wendy's, because if I do, I will regret it. It just simply causes indigestion, more or less.
Mm-hmm.
When they took mine out, I was basically 24 hours from dying. That was 2.5 years ago. They kept going on saying, why didn't you come in sooner? Why didn't you come in sooner? They kept saying about it hurting. I was never really in any pain. I just had a lot of bloating. Took Gas X, but it didn't really help. Finally went in. My doctor, when the nurse practitioner saw me, and she said, if we haven't called you in 2 hours with insurance approval, go to the ER and tell them that you're having this semblant and they need to do a CT scan. And I said, this sounds bad. She says, it probably is bad. Well, they didn't get it approved, so I went to the ER, and after I'd been there about a half hour, the doc comes in and says, we're sending you on to Lake Cumberland Medical Center. And I said, why? He said, because if you don't have that gallbladder out in 24 hours, you're dead. And I said, well, let me go move my car. And he said, no, we're sending you in an ambulance right now. And that's the story of how I got my gallbladder taken out. A lot of fun. I was actually lecturing, recording lectures from my hospital bed.
Oh, wow.
Believe it or not, though, I didn't miss a one. All my students stayed caught up. It's a good thing I'm not a cat, because cats only have 9 lives. As many close calls as I have, I'd be on my second set of 9 by now. But it's a good question. Main thing, again, I can't eat too much fat in one sitting, or it'll cause me some digestive problems.
Can you restate what you said for how the gallstones were made?
Essentially, the cholesterol gets too concentrated and comes out of solution. The hepatocytes might be making too much or releasing too much in the bile. You may have the gallbladder absorbing too much liquid from it. Whatever, it loses its solubility and it starts to crystallize. And once you've got something solid in there, well, you can see you're not going to dissolve it back. Do you have a question, Abby?
No, we have a person in one of my classes that just got his gallbladder out, and they actually thought he had alpha gout for the longest time.
Had what?
Alpha gout. It's like you get it from tick bites. It causes you to be really
Oh,
sensitive.
alpha gal.
Alpha gout.
Yeah,
Sorry.
okay.
Yeah.
I'm sorry. Well, no, I should be closer. I'm just too lazy to move.
It's okay. But
I don't hear very well.
So he just didn't eat anything for a while, and they found out it was his gallbladder, not.
Who was it? Really?
Bottom line, if I had a take-home message to give you from all this, it's pay attention to your body. The doctors always go with the most common thing because generally they're right, but it can end up being something odd. I thought you had said gout.
No, not gout. No.
Believe it or not, I have gout. It is a buildup of uric acid crystals in your joints. It's supposed to be quite painful from what I understand. And before you ask, mine has never caused me any pain at all.
Isn't it most common like in your feet, like your ankles?
One toe on my left foot looks like it has been smashed with a hammer. That's how swollen up it is with the gout. But it doesn't cause me any trouble at all. My doctor didn't really believe that. Again, I had just gone in to see the nurse practitioner, and she called the doc in. The doc came in and looked at it, and he said, yeah, that's gout. He poked it a couple times and said, you're not screaming. That's a good sign. Yes, I use myself as an example a lot. I've got so many conditions, why not, right? So any other questions about gallbladder disease? Essentially, it's just a sac to store bile, and the bile helps in the breakdown of those things we talked about with the liver. So everybody okay with that? We're ready to move on to the next section? Okay, the small intestine. We're back to the alimentary canal. It goes from the pyloric sphincter to the beginning of the large intestine. It is very looped and coiled. It fills most of the abdominal cavity. And in a living person, it's about 9 or 10 feet long. If the abdominal muscles were completely relaxed and you actually stretched it out, it could be anywhere from 18 to 20 feet long. And it has 3 regions. Number 1 is the duodenum.
Can you spell that?
Sure can. D-U-O-D-E-N-U-M. The second one is the jejunum. J-E-J-U-N-U-M. And then the final one is the ileum. The ileum. I-L-E-U-M. The duodenum is about 10 inches long, about 2 inches wide. It's the shortest part of the small intestine and the most fixed, meaning it has a very specific location and it's anchored there. This is where the bolus of food gets mixed with the pancreatic juice and the bile. And from there it passes into the jejunum. There is no line of demarcation between the jejunum and the ileum. The only real difference is the jejunum is typically wider. It has a greater diameter. It's got a thicker wall. It's more vascularized. And it has more activity. The jejunum is lined, well, really the whole small intestine is lined with very tiny projections that stick out like fingers. These are called the villi, V-I-L-L-I. These actually stick out into the center of the intestine. And what they do is they maximize the surface area that comes into contact with the digested food. And as you might imagine, they absorb the nutrients through their cell membrane. They also can be found on folds of the mucosa. These are called plicae circulares. Plicae circulares. And again, they just help increase the surface area, which increases absorption. The villi are lined with epithelial cells. These are some of the most rapidly dividing cells in the body. They're constantly being replaced. And you also have numerous glands that secrete mucus and certain enzymes to help finish breaking down the food. Peptidases, lipase, sucrase, maltase, and lactase. Page 704 or 219 electronic, table 17.9, does a really good job of summarizing all of the various enzymes that are involved in the digestive process. Table 17.10 summarizes the end products of digestion and how they are absorbed. And finally, we get to the large intestine. It's about 4 or 5 feet. And it kind of goes like this. Starts down here, goes up, across, and down. Kind of a U shape. The first part is called the cecum, C-E-C-U-M, the cecum. And this has a narrow sac-like tube that projects down, and that is called the appendix, A-P-P-E-N-D-I-X. And for a very, very, very long period of time, it was thought that the appendix had no specific function. That turned out to be erroneous. It does have a function. Does anybody know what it is? It is a reserve for bacteria. Actually, a safe house for bacteria. Now, that may sound odd, but every single one of us is hauling around about 1 or 2 pounds of bacteria in our gut. This is called the normal intestinal flora. The normal intestinal flora. When you have a severe illness that is accompanied by, say, severe diarrhea, or you take fairly strong antibiotics, you are going to end up wiping out your intestinal flora. The appendix serves as a kind of safe house for the bacteria to repopulate your gut from. It also has some immune function. And if that doesn't gross you out, what I'm about to tell you will. In certain cases, the appendix can become inflamed and infected. The bacteria start to grow there. We call that appendicitis. It used to be a fairly common occurrence to have your appendix taken out because of appendicitis. It used to be major surgery. If your appendix burst, if it swelled so much it actually burst, it really would make you septic, and that's real bad news. Now, just like so many of the other things, they do it laparoscopically. You just have tiny incisions. It's no big deal. But there have been cases where people have had chronic diarrhea and their gut flora, their intestinal flora, have never been able to sufficiently repopulate. And they have come up with a crazy sounding treatment that has actually proven effective. Malachi says he knows it. What is it, Malachi?
Isn't it where they take the feces of somebody else who has the healthy bacteria and they essentially just put it in you?
You got it. It's called a fecal transplant. They take poop from the donor and give it to the recipient.
What are the effects of having, like, no flora in the gut?
You're very, very susceptible to infections because the healthy bacteria that normally are found there, they actually help form a barrier essentially to any harmful bacteria that get ingested. They actually help in the breakdown of certain long chain polysaccharides. If you eat too many of those complex polysaccharides, the normal flora will give you gas buildup. So mainly it's all about balance. They help you break down some things, they help keep things in balance, and they actually help with absorption. It's a fairly complicated system. They actually call it a microbiome, B-I-O-M-E. And the microbiome is basically referring to your gut and the various species that live there. Abby looks like she has a question.
Yeah. So if you don't have an appendix, would you just kind of be more susceptible to like a longer healing process after having like gut issues or taking antibiotics?
Yeah, my ex-wife had celiac disease. Now, celiac is different because it's an autoimmune disease. She also had lymphocytic colitis, and that is another autoimmune disease. But to put it bluntly, if she got any gluten at all in her diet, it was essentially a poison. And it would give her a terrible case of diarrhea, to the point where we actually had to make sure that we kept sports drinks like Gatorade and things on hand to make sure she stayed hydrated. It got so bad that I actually went on a gluten-free diet with her. Not because I had any issues with it, but it was just so much simpler to not even keep it in the house. If we didn't have it, there's no danger of cross-contamination. And I mean, it would cause gas pains and bloating so bad she'd wake up crying. She had trouble walking a time or two. It was bad. I used to joke that I would cheat on my wife because I would stop by McDonald's and get my burger. And she said, what happens outside the house stays outside the house. But it was not something to joke about, really. We tried to have some sense of humor about it, but it was pretty rough stuff. Do y'all want to take a break right now? Let's take a break. All right. So back to the cecum. The next part is called the colon itself, the colon. The ascending colon, the transverse is what goes up the right side here. The transverse colon goes along here. Then you've got the descending colon. Ascending, transverse, descending.
I had no idea we had one that went across.
Huh?
I said I had no idea it went across too.
I didn't know that's how it was shaped.
Well, again, there's no real reason you would have. Studying the body is fun, but it can also lead to some surprising things. After the descending colon, you've got the very last part of it where it makes an S curve, and this is called the sigmoid colon. And then the very last part of it is called the rectum. Which becomes the anal canal and opens to the outside at the anus. And you have two sphincters there. The internal anal sphincter, which is smooth muscle and involuntary. And then the external anal sphincter, which is skeletal muscle and is voluntary. The large intestine is essentially there to recover water.
You said that the large was essentially there to
Recover water. And in cases of constipation or diarrhea, it generally has to do with something interfering with that balance. If you don't get enough water out of it, you get diarrhea. If you take too much out and mobility slows down, it's constipation. Do you have a question, Malachi?
no.
Okay. Very often, the bacteria that are located here will ferment the food. And this gives you ammonia as a gas and hydrogen sulfide as a gas. And that is one of the things that causes the foul smelling release of that. And it's very important that you maintain the proper balance there, because if you don't, you can alter that balance. So any questions about all of that? One of the things they worry about as you get older is colon cancer. It's not something that can easily be detected because it rarely has visible symptoms. So when you get to be of a certain age, generally on the north side of 50, you have to get a colonoscopy, where basically they give you enough laxative that it cleans you out completely, and then they stick a camera up there. It's not nearly as bad as it sounds, because they put you under when they do it. The prep, I will say, is horrible. But that's how they found the colon cancer in my best friend's wife. She's a year younger than me, and she was at stage 3, but they found it and they were able to do surgery and chemo, and she is now in remission.
When they do a colonoscopy, don't they give you like obviously when you have like a laxative, you have certain instructions that they say is on the bottle, but don't they give you different instructions when they do a colonoscopy that you're supposed to do?
Very often, yes. They have their own prescribed blend, and it tastes nasty.
And you have to put like a lot of it. It's like the ratio is way different.
Isn't it just like kind of magnesium, what is it, citrate?
Yeah, mostly magnesium sulfate. But trust me, you're drinking a lot of that stuff. And once you drink a lot of that stuff, you are never very far from your commode.
Don't they also require you to take that in some kind of surgeries? Like I know with some
Yeah.
colon surgeries.
I had to get up at 4 in the morning to make sure I got all of mine this past summer. And I was so glad he gave me a clean bill of health, and I don't have to have another one for 10 more years. But joking aside, it's definitely worth doing.
Yeah.
I want to get one. That sounds scary. What if I have colon cancer? I don't know.
You gotta get one? Is that what you said?
No, he's not having it.
You generally are not going to need one until you're over 50. If you have a condition, or they suspect you have a condition, they may require you to do one sooner than that. Like with my wife, when they were trying to figure out what was going on with her, they did one, and she wasn't 50 yet. But with me, I turned 50 and I let it go up until last summer. I finally decided to bite the bullet, and I made sure that I got signed up and kept the appointment, and my doctor did too, and we got it done. You know why you don't have to get it until you're over 50? What's the number one risk factor in cancer, more than anything?
Diet.
Huh?
Diet?
Did you say cancer?
Cancer, age. All other things being equal, out of everybody in this room right now, there is no question that I have the highest cancer risk. Because I have basically been on this mud ball 3 times as long as you all have, which means I've accumulated 3 times as much damage. Now, there are other factors that come into play. This is where diet can be a critical issue. But more than anything, it's age. And that is it for the lecture. So let's call it